Here's a look at the key for the midterm here. This first one, we've got a pressure vessel. What we want to do is find the hoop and axial stresses. Okay. Now that's the maximum minimum normal stresses in the tank. So the maximum normal stress is 9.6 megapascals. Now tau max in plane, because this is a biaxial approach that we'll take to finding tau max in plane, will be plus or minus sigma max minus sigma min over 2. So we got sigma max, we got sigma min, subtract and divide by 2, it's a plus or minus 2.4 megapascals. The maximum normal stress is the hoop stress. That splits the tank in half the long way, so that'll act like that on plane AB. The shear stresses act 45 degrees off of the plane of the maximum normal stresses, so that would be EF and GH for the planes of maximum shear stress, in-plane shear stress. All right, the next one here, we've got a rectangular plate. We've got the stresses shown applied. We want to find the new length for BC and the new angle ABC. This involves finding the strains. That involves Hooke's law. So there's Hooke's law. We've got the stresses that are given. There they are, right above here. We plug those in and we use E. So 1 over E sigma x minus nu sigma y. And that's negative 0.07. So that means the line from B to C there gets shorter by 7%. So that's 30 centimeters times 1 minus 0.07. That's 27.9 centimeters. The shear stress, or excuse me, shear strain then is the shear stress over G, which is 0.16. What that is the change in that angle there in the on the XY planes. So that would be angle ABC. It's getting smaller because a positive shear strain means the angle is getting smaller, so it's getting smaller by that amount. And what that is, that's radians. We can consider that to be a radian measure. So if we take our original 90-degree angle, which is pi over 2, minus, and that's radians there, minus 0.16 radians, then convert that into degrees, we'll get the new angle for ABC. Okay, the next one there, we want to find out, we got point O as our reference. We want to see where point A will end up. We've got the strains in the X, Y directions, as well as the shear strain there. So we've got the X strain is getting larger, it's lengthening out. The Y strain is getting smaller, so that's a negative. Okay, so the length there, I guess I should say, in the Y direction is getting smaller, so that's a negative for the strain. All right, we can find the normal strain at 45 degrees, use the normal strain equation there. That gets you 0.1. We also want to know how that line OA is rotating. That's found by using alpha. So we plug into the alpha equation and find alpha for 45 degrees. That's negative 0.22. So what happens here is we're using our radius here as our reference line. Each large square is 20% of the radius because there's 5 large squares in the radius. So it lengthens out in the 45-degree direction, 0.1. So that's about half of a large square. The negative on the alpha means clockwise. That's 0.22. So that comes over a little bit more than 1 large square there for the alpha. So there's the final position there of point A. All right, the next page here we find some moments of inertia, pi over 2 r to the 4 for solid shaft, pi over 2 outer radius to the 4 minus inner radius to the 4 for a hollow shaft. For the next one there, we want to find the torsion. That's the moment about the center of the shaft. Half of 9 is 0.045 meters plus 0.02 is 0.065. Find the weight. That's 1373 newtons. Multiply that by the 0.065 distance. You get the torsion, 89.25. For the power there, you take 1200 revolutions per minute, convert that into radians per second. Multiply that by the torsion, which is 600 pound-feet, and then convert that into horsepower. 1 horsepower is equal to 550 foot-pounds per second. You get 137 horsepower. The next one, we want to find the twist of point B. To do that, we first find the reactive torsion, which you can find there by taking the sum of the torsions plus the reactive torsion. The reactive torsion comes out to be 330 Newton meters. Okay, then we can find the torsion in the section from A to B. We've got 330 for the reaction. When we find that torsion in AB, it's 330 going into the page as shown. Then we just do phi as TL over IG, so the negative 330 for the torsion, 0.8 for the length. We got I, and then we divide by G. It's 0.0364 radians. It's negative. You can convert that into degrees. It's negative 2.09 degrees. So that's the twist of B with respect to A. Okay, the next one, both the maximum shear and maximum normal stress are TR over I. We've got the torsion there, 900. We've got the radius, which would be half the 9 centimeters, so that's 0.045 meters. Divide it by I, you get the maximum shear and normal stress there, 6.29 times 10 to the 6. That's a plus or minus for both values, so 6.29 megapascals plus or minus for both answers. Now, if you look at how these torsions act, this one on the right rolls down across the shaft. The reactive torsion on the left will roll up. That gets us to these shears right here. Okay, the other two will meet in the corners as shown. All right, so there's your shear sketch right here. Now that leads us to the normal stress sketch, which acts at 45 degrees. So the shears are are at 0 and 90 degrees. So the maximum normal, that's the maximum shear. The maximum normal stress will be on the 45-degree planes then. And it's just a matter of combining these shears together, 2 at a time, to get to the normal stresses. So I could take these two here, and that will get me this normal stress. I'm adding those like vectors and getting a shear like that, or excuse me, a normal stress like that. I can then take these two, add them up, and get a normal stress like so. That acts right there. I can then take, let's see, these two shears here, add them up like vectors. They'll act like that. So that gets me this normal stress. And then I can add these two shears here as vectors. They'll get me a normal stress going that way. So there's the normal stress sketch. Okay. Okay, the last one here, we have these limiting values right here. We just take the equations, tau max is TR over I, and rearrange that, solve it for T. Do the same thing for the normal stress is TR over I, solve that for T. We also have a limiting angle there. We want to convert that into radians, of course, so that's 0.0349 radians. Take the phi as TL over IG and solve it for T. It's phi IPG over L. So just run each one of those equations to get 3 values of torsions that would cause those different values. So 8587 Newton meters will get you a shear stress of 60 megapascals. 6583 Newton meters will get you a normal stress of 46 megapascals. And 7492 Newton meters will get you an angle of twist of 2 degrees, which is 0.0349 radians. Pick the one that governs, which is the lowest value. So for this shaft, you can go up to 6583 Newton meters. That would be the maximum allowable torsion. Once you go beyond that, you've got too much normal stress. All right, so that's a little run through that. Now that's 2 of the midterms. You know, I know that people sometimes start thinking about their final grade in the class. So just to help you with that, remember that I don't use Moodle to calculate your grade, okay? I don't do that with Moodle because I use a system that's kind of complicated and I can't really get Moodle to do it. So what I have here though is I have a spreadsheet, a grade calculator spreadsheet right there. You can download that if you like. Okay, there it is. All right, Probably want to enable editing there, and then we'll have a look. Now what this is a nice, fairly simple spreadsheet, and the purpose of this is to get you some idea what sort of final score you might need to get a certain grade. So let's say that you can look at your homework score in Moodle and put that in, and then put in your two midterm scores. Let's say you've gotten a 76 and a 72. Okay, and then you want to know what you would need to do to get a B. And you could just put in different final scores and see. Looks like 85 is actually pretty close. Now what I've got here are both systems that I use to calculate grades. Okay, so method 1 and 2, the top row shows the percentages that are assigned to each score. The bottom row calculates based on your scores what the values would be. The total is right here. To get a B, you need a 79.5. I'll take the better of the two when I do my grading. I essentially have a spreadsheet just like this. This is why I don't use Moodle to grade. It's hard to get Moodle, the spreadsheet embedded in Moodle, to do this. So I just use Moodle to list your scores. I don't use it to calculate a grade. So what you could do then is play around with your scores here. We could put in an 80 for the final. That's going to not quite do it, but we could put in maybe an 82, let's say. There we go, 79.5. That would do it right there. So that would be the grade that you need to get a B in the class. Okay. So if you're curious about that, you can have a look at the spreadsheet there.